In this last section, we're going to look at another way that we can find percentages. We saw from the previous section that when you're finding percentages and you're using the 68, 95, 99.7 rule, it can be a little awkward to find percentages. So instead, we're going to find percentages using our z-score. So just to review, a z-score is a data item. We subtract the mean, and then we divide by the standard deviation. So here we have a z-score and percentile chart. For every z-score in this particular chart that I have goes from a -4 z-score to a +4 z-score. So for every z-score, it's going to correspond to a percentile. So this percentile is written as a decimal, but it doesn't have a percent sign on it. So we can assume that there's a percent there. So remember what the percentile tells us. It tells us the percentage below. So if your data item has a z-score of -4, that means that 0.003% of all the data items are below this particular data item. So for every z-score in this table is going to correspond to a percentile, which is the percentage below. And the percentage below is the important part here. So let's go ahead and look at example 1. We want to find the percentage. So again, we're asked to find a percentage of data items in a normal distribution that lie below a z-score of 1.4, above a z-score of 0.6, or between z-score of 0.6 and 1.4. So we don't want to use the 68, 95, 99.7 percentage because these are odd z-scores, like a 1.4 and a 0.6. This is not like a z-score of 1. Where remember the z-score is just your standard deviation above and below the mean. So since we're going to find a percentage and we're given a z-score, that tells me that I'm going to use this z-score percentile table. Part A. To find the percentage of data items below a z-score of 1.4, well, all you have to do is look to the table, look for a positive 1.4 z-score, and we see that it's down here. So a positive 1.4 z-score corresponds to 91.92. This is the percentage below. So all I have to do is take the 91.92 and tack on a percent sign. I don't have to adjust it in any way. All I have to do is put the percent sign on. B, we have to be careful because we're looking at the data items that are above a z-score of 0.6. So let's first go to a z-score of 0.6. And a z-score of 0.6 corresponds to a percentile of 72.57. So remember, that means that 72.57% of our data items are below this data item with a z-score of 0.6. We want a above. When we're dealing with percents, we're always dealing with 100%. So if all of our data items are represented by 100%, and this corresponding percentile of 72.57 is the percent below. That means if I take away 72.57%, what remains must be the percent above. So when you're asked to find a percentage above, and you're using this z-score percentile table, you need to subtract that percentile from the total of 100%. However, remember that was a z-score of 0.6. So 0.6 gave me 72.57% below. Let's look at negative 0.6. I want to point something really interesting here. So if we go to a negative 0.6, where are you? Here we go. Negative 0.6 corresponds to a percentile of 27.43 or 27.43%. Remember, that's the answer that we got for part B. So a shortcut to finding the percentage above is to look at the opposite z-score. If you have a positive 0.6, look at the negative 0.6. If you have a negative 0.6, look at the positive 0.6. Okay? So you would either subtract from 100 or you would look at the opposite sign z-score. Let's look at part C. We want to find the percentage of data items that fall between a z-score of 0.6 and a z-score of 1.4. Whenever you're asked to find between, you simply subtract the smaller from the larger. And you don't have to do any adjustment. You take the exact percentile that's given to you in the table. So if we looked at the percentile that goes with 1.4, that was a 91.92. Okay? So 91.92% below. We're going to subtract the exact percentile that goes with the 0.6, and that was the 72.57. So when we do this subtraction, we get 19.35. So 19.35% of our data items fall between a z-score of 0.6 and a z-score of 1.4. So whenever you're looking for below or between, you just take the exact percentile, tack on a percent sign. Whenever you're looking for above, you do have to make that adjustment because the table only gives you below. This is the last page of examples, and then we're actually done with our course material. Example 2, the distribution of monthly charges for cell phone plans in the US is approximately normal, with a mean of $62 and a standard deviation of $18. What percentage, so that tells me I'm going to use the z-score percentile table, what percentage of the plans have charges that are less than $83.60? So the percentage less than or the percentage below 83.6, well, I have a problem. 83.6, that's a data item. The $62, that's the mean. The standard deviation is $18. I don't have a z-score, so I cannot use the table. So sometimes you're not given the z-score. You have to first find the z-score. And in this case, it's for the data item of 83.6. So we have to first find the z-score. So it's data item 83.6 minus mean of 62 divided by our standard deviation of 18. So in my calculator, I get that this is 1.2. When I go to the table, 1.2 corresponds to a percentile of 88.49. Since this is the percentage below, and I'm looking for less than or below, I'm done. I just have to tack on a percent sign. Let's look at another one. We'll go back to female adult heights in North America. So remember, they're normally distributed. We have a mean of 65 inches, standard deviation of 3.5 inches. What percentage, so I'm looking at the z-score percentile table, of women have heights that exceed 69.9 inches. So exceeds means it's greater than or above 69.9 inches. So think about that. The 69.9 inches, that height is a data item. The 65 inches is the mean. The standard deviation is 3.5. I don't have a z-score. To use the z-score percentile table, I have to first compute the z-score for a height of 69.9 inches. So that's 69.9 minus the mean of 65 over the standard deviation of 3.5. When I plug that in my calculator, I get a positive 1.4. When I look at the table, the percentile that corresponds to 1.4 is 91.92. So remember, that is the percentage below. I want the percentage above. So I would either subtract this from 100 and get 8.08%, or since I'm trying to find the percentage above, I would look at the negative 1.4 z-score. And if you look at the negative 1.4 z-score on the table, that corresponds to 8.08%. So again, just be careful if it's above or below. So our last example is the distribution of the life of refrigerators is approximately normal. We have a mean of 14 years, standard deviation of 2.5 years. What percentage of refrigerators have lives between 11 years and 18 years? So again, we're looking for a percentage. That tells me I'm going to look at the z-score percentiles table. Again, I have data items here. I have the 11 years and the 18 years. Those are data items. I have a mean of 14 years and a standard deviation of 2.5 years. I don't have my z-score. So since I'm looking at 11 years, 18 years, I'm looking between those, I have to compute the z-score for 11 years, the z-score for 18 years, and since it's between, I'm going to subtract the smaller from the larger. So for a z-score of 11, that's my data item is 11, I subtract the mean, which would be 14, and I divide by the standard deviation of 2.5. And that gives me a negative 1.2. That corresponds to a percentile of 11.51. When I look at the z-score of 18 years, it's going to be 18 minus 14, the mean, divided by the standard deviation of 2.5. That would be a positive 1.6. When I look at the table, positive 1.6 z-score corresponds to a percentile of 94.52. So remember, between just says that we're going to take the larger and we're going to subtract the smaller. When I do that subtraction, I get 83.01%. So 83.01% of all refrigerators have lives between 11 years and 18 years. And that's actually it for this section. All we're doing in this section is using our z-score percentile table to find the percentages of data items that either lie above, below, or between. That is it.